data analysis. Data analysis already we have covered either in QT or PRM. So when you talk about descriptive analysis, we do carry out visualization, try to understand the data, right? So that is something called exploratory analysis. Also, exploratory data analysis means you are exploring the data, trying to find out what does this data talks to you, right? So general conditions are mean, median, mode, some kind of relationship, scatter plot, bar diagram, a pie chart. Generally, we avoid pie chart, but those are the data visualization, minimum data visualization or analysis you have to do to understand what does this data tells you about, right? Basic things. Then based on that, if you have some business objective, like I have given you 4 business objectives to understand certain research objectives, to understand whether funding is greater than something, or comparing two groups, comparing few groups like that, right? Or finding out certain relationship. So whenever we have one group of data, right? So that is when we have univariate, one variable, right? So we have only one information about only one variable, right? Then only univariate. Bivariate means two variables. So one sample t-test is an example of univariate. Two sample t-test, cross tabulation, right? All those are example of bivariate. Correlation. Correlation Pearson's R is R coefficient between two continuous variables, that is bivariate data analysis. Multivariate data analysis means more than two, right? Multiple variables. That is when we did some regression analysis. Your salary is dependent on ANOVA 3. So whenever you are carrying out a two-factor ANOVA, you might have three variables, right? Two independent, one dependent, right? So that is when you will have multivariate analysis. Then once you enter second year electives, right? In case some of you take into marketing research or different analytics kind of courses or analytics toolbox, right? So there are additional itself. So that is when you carry out like conjoint analysis, factor analysis, then cluster analysis. There is something called multi-discriminant analysis, right? So there are different methods. Logistics regression, I think some of you might have covered. Those are the additional techniques which will come under multivariate data analysis method. Will be covered in different courses, right? So that data analysis method, once you practice, you will be able to kind of expertise on that. So that won't be a big challenge. The big challenge will happen in the first 5 steps, right? Validation of data, right? How to make sure that the information what you have collected is correct or not, right? So there is no kind of a handbook or a guide to understand whether information you have collected is correct or not. There are certain thumb rules, right? If you know that, okay, so the like let's say you are doing this research for ITC distributors, you know that somebody's income cannot be more than 100 crores, right? But people have put like that, right? You know that by mistake either he has put it or the, so it can be a problem might be in the respondent side who is providing you the data, right? Knowingly or unknowingly he or she has done certain mistakes, or the researcher who is like kind of, sometimes what happens, will go to a field and collecting data standing in front of a store, right? So mostly FMCG research will happen like that, right? You have to visit a lot of stores and collect data, like a face-to-face interaction, and you will be collecting data either in your mobile phone or in a notebook, right? So while writing itself, it might be a kind of issue, right? You do not remember what was that, what did you write that day, right? So one good thing is to, like, every day when you are collecting data, come back and kind of write down or put that data in a tabulation format, right? So the problem will happen if you have a field research, you are going to company collecting data. So you'll say that, okay, let me collect data for 15 days. Then after that, I'll consolidate. And suddenly what will happen, you will not remember that day what exactly you wrote. Your own handwriting or somebody has given in writing, you will not able to read it out, right? So ideal case scenario is that on the day you are collecting data, you tabulate it, right? You put it in Excel file or whichever format you want, right? So curve stoning is the process where cheating or falsification in data collection process. So it might happen both in your respondent who is giving you the data, or from your side also, right? It is not that always you'll be writing correctly, right? Sometimes people do falsification of data, right? And that is where your results also will be incorrect, right? Then the editing part. Uh, One of the biggest challenge in editing or data cleaning is missing data, right? Like right now, Sai was mentioning, lot of information is not available. Let's say 200 data points information per startup is not available. How to interpret that, right? Sometimes it will not be possible to interpret. Sometimes, like in this particular case, if I do not know that whether it is from the private equity or kind of seed funding has happened, how will I make sure, right? But in some cases, survey data. So this is a secondary search data where you have a, ideally I should have that information or you should have that information. But in some cases, let's say you have a survey data, you are collecting responses from the individuals, right? Replace missing value with a value from the similar respondent, right? What does it mean? If you know that that is a male student, MBA student, monthly expenses is around 1,000 rupees or 1,500 or 2,000 rupees. That is the, you have an idea, or for the last 10 respondent whom you have contacted, so they have told that kind of answer, right? So for a person who has not mentioned monthly average expenses, you can impute that value. You can take that as a 1,500 or 2,000. So replace missing value with a value from a similar respondent, right? In that same age group, same income group, what is the average expenses for that kind of person? Or for that particular person, let's say I have asked a question, do you prefer to go outside or do you like going out with friends, right? And in a scale of 1 to 5, strongly disagree to strongly agree, that person has told 5. That means that person is generally go out, like to
Agree.
go out, right? So in that case, what happens if I have another question, how frequently you go out, or whether it is in a scale of 1 to 10, that person has not answered, because previously he has answered similar question where he has said that okay, he actually likes to go out. Then I can take a proxy for that. Yes, in this case also, in this answer also would have been in the right hand side. You would have frequently gone outside, right? Frequently gone out with friends for movies or outings or traveling, all those things, right? So this is where for the same person, whatever similar type of questions I might have asked, so I can take a proxy for that. Third thing, generally for the kind of which is much more preferable in a continuous data, right? So in this particular case, let's say this data set which I have given you for a particular, let's say, healthcare startup, right? So that startup is mentioned, the industry vertical is mentioned, sub vertical is also mentioned, right? But the startup funding is not mentioned, or private equity is also mentioned. But what is the funding? It is not mentioned, right? One way is to do not consider at all, which right now so I was asking. One way is to, like, if your data set size is big, right? Let's say I have 1,000 rows of data, 500 rows of data. If 10, 20, 50 rows are missing, up to 20% of the data is missing, I can still do not consider in my like kind of calculation, right? But if you know that lot of data are missing, right? So 50%, the 30% of data is missing, so you should not disregard them, right? One way is to, if it is a continuous data, what you can do, let's say if I give an example, let's say healthcare startup is there, right? Industry vertical is mentioned, startup name is mentioned. So sometimes information is not there, you will just search in Google what was the funding for that startup from private equity or seed funding, right? So you search in Google, you find that data, you replace that in your like data set. Let's say you did not find in Google, right? So what will happen? Let's say health startup, industry vertical is health, then other subsector is also given, private equity is given, right? What is the average funding per health startups from private equity? Let's say it is 1.5 million or 1.2 million dollars, right? Put that value for this startup, right? So sometimes what will happen, we impute average values, right? Average number of values, and that whenever missing data is there. But it is not that for all the values you can do it like that. So you have to be careful, right? So whenever you have all the necessary information, only one field is missing, then you can do that. But let's say nothing is there, industry vertical is not there, sub vertical is not there, whether it is a private equity seed funding is not there, right? Ideal in that case scenario, you just put it in others, ignore that, right? Do not take into consideration while carrying out data analysis, right? So these are the actual live problem we'll face. One is a problem with the data set, either problematic data, incorrect data. Second is missing data. These are the two major problems which you'll face in your real life whenever you carry out a research or any kind of data analysis, right? So this is somewhere like again later on there are advanced methods, advanced techniques to take care of these like kind of issues. But at least missing data, these are the basic simple steps which you can kind of remember and practice when carrying out data analysis. Third mistake generally happens. I'll not say mistake. Third kind of miss which happens when carrying out writing a questionnaire. Let's say I'm carrying out a survey, right? A Likert scale, strongly disagree to strongly agree. Ideally, I should code that data. I should put some coding, numerical value to this definitions, right? Strongly disagree means generally if I put in a scale of 1 to 5, strongly disagree mean 1, strongly agree mean 5, right? Ideally, I should put that coding. So that is what coding means, not that the actual coding what you know so far. Coding in data research means or business research means putting some numerical definitions to a theoretical definition, right? Or the like kind of statement, right? Male and female, like I showed you in the last class, right? Regression we are discussing categorical data, right? So I had taken male as 0, female as 1. So that has to be clarified in the beginning, because when you are carrying out data analysis in SPSS or Excel, it is always better to put some number and carry out data analysis. So that doesn't mean 0 or 1 has a meaning. 0 and 1 in that particular case is only for identification. So 1 doesn't mean 1 is better than 0 or 0 is less than 1, right? In that case, only for identification. But what happens when you put in SPSS, the data for diagram creation or any kind of data analysis, it becomes easier because reading this numerical data is easier for a software, right? Or even in Excel also, right? Just imagine if I've written a full statement, how do you like how frequently you like to go out, right? For that question, strongly disagree, strongly agree, neither agree, disagree, like that responses has come. So putting that in a bar diagram becomes very difficult, right? So all the statement will be written, your bar diagram will be very clumsy. So rather than writing full statement or definitions, if you write 1, 2, 3, 4, 5, then in the same presentation you write 1 means strongly disagree, 5 means strongly agree. So your representation becomes little bit easier, right? So this is what coding means, providing numerical values to a kind of labels or statements of categorical data, right? Then data entry tabulation, right? So this is what I was talking about. Anytime you collect data, right, try to tabulate kind of at least start from the beginning. Do not end, wait till the end. Sometimes what happens if you have collected data on your notepads and all those things written data, it gets missed out, right? One-way tabulation means put in rows are respondents, columns are variables. Two-way tabulation or cross tabulation means variables both will be in rows and columns, right? When we did cross tabulation, one set of variables we put in rows, another set of variables in columns, right? Then we did something known as a chi-square test or a cross tabulation, right? Uh, Coding, I explained. So generally we put some codings to the labels or explanations, right? So just to give an example, if a research is being conducted for DBT rental, right now obviously nobody rents DBT, right? Earlier 20 years, 15 years back, CD or DBT people used to rent. So what is my variable name? What is the in SPSS if I'm conducting that data analysis? What is that variable name in SPSS and how that is coded, right? Movie rentals, rent, because in shorter names is preferred. Then how am I coding it? Somebody who has rented frequently movies in DVD format. Yes, two means no. That doesn't mean two is better than no. It is just only how you are representing, how you are identifying yes and how you are representing no in kind of in your SPSS or Excel, right? Same thing here. What kind of movie genre that person has rented movie, right? One comedy, two action adventure. Data visualization analysis becomes little easier when if you have coded. It doesn't mean that if you have not coded, it cannot be done. That becomes little clumsy, right? So these are certain best practices you have to remember. Then obviously I have discussed univariate, multivariate. So when I say discussed, these are certain functions in Excel. Most of you know a count of data, average, median, maximum in a range. If I want to find maximum value in a range, minimum value in a range, right? So these are the functions. Variance we have discussed, standard deviation we have discussed. Uh, univariate, two variate, multivariate. Multivariate is these are the some of the analysis we have already done: cross tabulation, ANOVA, multiple regression. Later on in your second year, in case some of you take other subjects, we'll get into discriminant analysis, MANOVA, canonical correlation. When I want to find correlation between multiple variables, more than two variables, right? Then there is something called multiple discriminant analysis, linear discriminant analysis, or multiple discriminant analysis, cluster analysis, multi-dimensional scaling. So this is a good method. MDS is a good method to carry out this positioning map, right? Competitor analysis. Where does my product or company lies with respect to competitors, right? Then factor analysis, right? So these are the additional methods which you'll learn in the second year. In the first year, it is what we have covered only, I think, cross tabulation and regression.